Hello and welcome to the Math Bender. I'm Adnan Zaidi, and in this section, we'll discuss further trigonometry and what are obtuse angle identities. Let's start. So let's say if this is a circle with a radius r, and this point here, which lies on the circle, has some x, y coordinates. And I can write this as this height is some y and this is some x. And I can say that sine of angle A, let's call it A, is y over r because it is opposite over hypotenuse. Now the circle has dynamics in such a manner that if this point revolves and reaches this point somewhere here, so let me draw that out. So if this is r again, it will have the same y and same x. And I can say that since sine of an angle is the ratio of y over r, it is also sine y over r. Now notice that the first angle that I've drawn, A, and let's call this for a moment B, they both have the same y over r. And since we measure the angle, if you see that the second one, the red one, is in the second quadrant, which means the angles which are greater than 90 and less than 180. So since they both are exactly the same, we can write this that sine of angle in acute quadrant. Acute quadrant means the first quadrant here. In the first quadrant, sine of an angle of an acute is equals to sine of an angle in obtuse quadrant. And if you want to write it mathematically as an identity, I can say sine of, let's call it x, is as same as sine of 180 minus x. So both the angles in acute quadrant and in the second quadrant, they have sine exactly the same. I can give you an example. Let's take x as 40 degrees. So if I try to find out sine of 40, I can say that zero 0.64. I'm keeping it up to two decimal place. And if I write sine of 180, since I've taken x as 40, so 180 minus 40 is 140. It gives you exactly the same answer. So from here, we can write that this is our first identity because in obtuse angle and acute angle sine both are same. Let's take an example for cos here. If I draw the same radius r, let's draw radius r here as well. I'll quickly go over through. So if this angle, and this is that coordinate x comma y, now, and the cosine of this is going to be, this is x, this is r, this is y. I can write this as that cos of, let's call this x, is equals to, since adjacent over hypotenuse is going to be x over r. But in the second quadrant, notice that when I say second quadrant, it means all the angles from 90 to 180. This one. This is the second quadrant. Here, the x coordinate is not positive. It is x and y. And if a situation comes where exactly this y is here, And this, according to this angle, this is going to be some negative x. And if I find out the cos, I'll say that cos of, let's say this is A, is negative x over r. So if we try to conclude that the angle in obtuse quadrant of cosine is negative of the angle in acute quadrant, or vice versa, I can say that cos of x is negative cos of 180 minus x, because if you see the angle A, it starts with this. We measure the angle from the zero line. By the way, this identity can also be written as negative cos of x. You can write it anyway. We can try to look at it. So let's say cos is 43. So x is, if I take x as 43, should be equals to negative cos of 43. So if I take that out, so this turns out to be minus 0.73. And if I write 180 minus 43, it gives you negative 0.73. Hence, they both are same. So in short, the angle in sine are exactly the same in obtuse, but in angle in cosine are just a sign, you just have to change. Rest, all of them, the magnitude is the same. So let's move forward and see some of the examples. So it's a non-calculator question. They have given you these values. So I can write this as, for this part A, I can write sine of 148 according to our identity. I can say that sine of 180 minus 148, and sine of 148, which I don't know what that is and I can't use calculator, but if I subtract 180 minus 148, I can see that it is going to be sine of 32, and sine of 32 is already 0.530. So sine of 148 can also be written as 0.530. Let's check another example here. Cos of 35. So since I know that cos of, let's write the identity, equals to negative cos of 180 minus a, and I can say that cos of 35 can also be written as negative cos of 180 minus 35, because I've taken a as 35, and cos of 35 is equals to negative. So since you subtract 180 minus 35, which gives you negative cos of 145, and 145 is negative 0.819. So negative 0.819, which gives you a positive 0.819. Let's see some more practical examples. Now let's look at this question. Now if you see here, it's a right angle triangle. As I can say that this is, let's call this x, angle x. The outer angle, since this straight line, I can say that this is 180 minus x. The question asks you to find this sine of angle ABD. Let's highlight it. ABD. This is what they are talking about. So I can say that if I have to find out sine of angle ABD, and I've already named it as sine of 180 minus x. And according to our identity, the value of sine in obtuse quadrant is as same as sine of x. So rather than finding out sine of 180 minus x, we know how to find out sine of x, which is opposite over hypotenuse. So I can write this as sine of angle ABD is equals to sine of x, which is 8 over 10, or 4 over 5, writing them in its simplest form. So let's look at another example of cos of dBA. ABD and dBA both are the same angles. So cos of angle dBA, we know that cos of dBA, we already named that as negative 180 minus x, is equals to negative cos of x. So all I have to find is cos of x. So cos is adjacent over hypotenuse. Then I can straight away write this as negative 6 over 10 or negative 3 over 5. So cos of angle DBA is negative 3 over 5. You could have written it as ABD as well. That's okay. Tan of CBD. So looking at tan of CBD. Now let's highlight that angle. C, B, and D. If you see, that's straight away asking for the acute angle, which means we are still in the folds of that right angle triangle. So it's asking for straight away tan of x. And we already have studied that tan is adjacent over, opposite over adjacent. So opposite here is 8 and adjacent here is 6, or we can write this in the simplest form, 4 over 3. That is the answer. So let's look at another example. Now, if you see, find the value of x in that right angle triangle, as you could see, you have two sides given, you have to find out the third one. So when we have two sides given and we have to find out the third one, the best way is Pythagorean theorem. And we know that the hypotenuse is this. So I can write straight away 41 squared is equals to 40 squared plus x squared. And 41 squared minus 40 squared is equals to x squared. Now, 41 squared is 1681 and 40 squared is 1600 equals to x squared. So since x squared turns out to be 81, or taking root both sides, x turns out to be 9. So I can write this as 9. Now next step is you to find out sine of PRS. So this is what they're talking about, this big angle. So this angle, let's call it x. The inner one will turn out to be 180 minus x. So I need to find out sine of PRS, which already named as x. We can say that it is as same as 180 minus x. So sine of x is going to be sine of 180 minus x, which is, according to that, this is the opposite and hypotenuse is 41. So sine of x, or sine of PRS, is 9 over 41. You can't further simplify that. Tan of PRQ. So PRQ is already in a right angle triangle. It is as same as we have been solving in the previous lectures. This is going to be opposite over adjacent, which is 9 over 40. Now the last part is cosine of angle PRS. We already have written that angle as x. We know that cos of x is negative cos of 180 minus x. And rather than finding cos of x, we can straight away, since we have already written that they are equal, we can write this as negative. Cos of 180 minus x is adjacent over hypotenuse, and in this scenario, it is 40 over 41. And we are done with that. So these are more or less paper 1 questions where calculators won't be allowed. And all you have to do is take out their basic trig ratio, which you already are aware within a right angle or in acute angles, and use that help to find out the angle in obtuse quadrant. This is it. I'll see you in our next session when we talk about different areas of triangle. Until then, take care. Bye.